Imagine trying to fry your morning egg on a pan made entirely out of wood. The wood wouldn't cook your breakfast, it would simply burn. Or picture an electrician trying to wire up a new house using long, thin strands of coal. The energy wouldn't travel a single inch. This table is our universe's master inventory. Out of the 118 known elements, we have learned how to select the specific material for every job on Earth. Every engineering choice we make relies on a strict separation. The entire elemental toolkit is split into two distinct categories: metals and nonmetals. Learning the rules that govern these two groups is how we reverse engineer exactly how our world is built. Long before modern laboratories, the blacksmith's forge was the testing ground for elemental properties. When you drop a material onto an anvil and strike it with a heavy hammer, its physical nature reveals itself. Metals possess malleability. Instead of shattering under physical stress, they absorb the impact and flatten into thin sheets. You see extreme malleability every time you use aluminum foil. We can beat a block of metal down until it is thin and flexible enough to sit in a kitchen drawer. Strike a nonmetal with that same hammer, and the result changes. Non-metal materials like coal or sulfur are brittle. Hit this pile of carbon with an anvil hammer, and it will instantly shatter into 1,000 pieces. You can even hear the difference. Metals are sonorous, meaning they produce a ringing note when struck. A nonmetal emits a dull, heavy thud. This difference in physical resilience dictates our infrastructure. We use metals to forge our tools and build our structures, and we use nonmetals as fuel. But physical strength is only half the equation. Take a look at this screwdriver. Its design relies on how different materials handle invisible energy. Metals possess a property called ductility. This is the specific ability to be stretched and drawn into long, unbroken wires. Those metallic threads are hidden inside the walls of every building, creating the copper highways that move power. Metals possess high conductivity, allowing heat and electricity to flow through them. Nonmetals act as insulators, blocking that flow. That's why the screwdriver is split in two. The metal shaft conducts the physical force needed to turn a screw, while the non-metal plastic handle exists to block electrical currents and protect your hand. There are exceptions to these rules. Not all metals are tough. Sodium is a metal so soft you can slice through it with a kitchen knife. Then there is mercury. It ignores the solid-state rule entirely, existing as a liquid at room temperature. Even with these quirks, the engineering remains the same. We move power by combining the flow of metals with the resistance of nonmetals. These elements are not just static building blocks. When exposed to air and water, they begin to react. Metals have a chemical weakness called corrosion. Copper slowly turns green, and silver tarnishes as they interact with their environment. When iron is left exposed, atmospheric moisture triggers a reaction that creates the brittle, flaking red layers we call rust. This decay eats through load-bearing beams and pipelines, requiring billions of dollars every year in infrastructure repair. While metals degrade slowly, certain nonmetals react with extreme speed. If you expose white phosphorus to simple atmospheric oxygen, it will instantly burst into flames. Understanding an element means knowing its strength on day one, and knowing how it will eventually react when exposed to the world. Modern cities are built from these specific properties. Every steel beam in a skyscraper and every mile of cable in a power grid is a result of malleability and conductivity. While metals provide the skeleton of the industrial world, nonmetals provide the foundation for life itself. This diagram shows exactly what you are made of. Your body is almost entirely composed of nonmetals. Oxygen for breathing and carbon for cellular structure are the anchors of our biology. Without the specific chemical properties of these non-metallic elements, life would be impossible. Every tool we hold and every breath we take depends on this fundamental divide. We rely on the conductivity and strength of metals to build our civilization and the biological chemistry of nonmetals to inhabit it.